Here we're asked to graph each function below. So first one is a exponential equation. Looks like -7 is my k value, which tells me my horizontal asymptote, because normally it starts off at y equals 0, but in this case we have a k value, shifts it down 7 units. So that's my horizontal asymptote. Now I'm going to choose a couple of x and y values to plot here. The first x value I'm going to choose is 0, because when I plug in 0 into this exponent, 3 to the power of 0 is 1. 1 times -2 is -2. -7 is -9. So 0, -9 is my first point. And we notice it's below that horizontal asymptote, which makes sense because it's a negative exponential function. Second number I'm going to plug in is 1. Again, just to make math easy here, I plug in 1 into my exponent. It becomes -2 times 3, which is -6. And -6 minus 7 is -13. So this is not to scale, but this is -9, -13. And my graph here, oops, that's wiggly. Let's try that better. That's a little bit better. And so there's my exponential function graphed. Okay, on to the log function here. Similar idea, starting off with the asymptote. Log functions have vertical asymptotes. And so starting at 0, it's shifted 2 units to the right. So I have a vertical asymptote at 2. And then I'm going to plug in some x values that make the math easy. So for the first one, I'm going to plug in 3, because that will make the inside of the log 1. And we know that log base anything of 1 is just 0. So that becomes 0. Then the next x value I'm going to choose 8, which I know seems random, but the reason I chose that is because when I plug in 8, 8 minus 2 is 6. Now the base of my log matches the inside of the log. So I chose an x value that made it so that the inside here matched my base, because then I do log base 6 of 6, which I know is 1. So if I plot those points here, that's 3, 0, and then 8, 1. A real sharp turnaround here for my log function. And there's my sketch.